we are going to be solving this example. This example says third root of 4 raised to the power of 2x is equal to 16. Now, I told you guys before now that whenever I see third root like this, it's the same thing as raised to the power of 1 over 3. So this third root, we are going to change it towards to 1 over 3 raised to the power of 1 over 3. So this is equal to, so from here we can say this is 4 raised to the power of 2x multiplied by what? 1 over 3. We're going to have it like this is equals to this 16. We can raise 16, we can say 4 raised to the power of 2, which is equals to 16. We have not changed anything. This is 4 raised to the power of 2. This is the same thing as 16. We have not changed anything. Now they are now both having the same base. We can decide to what? Eliminate the base and equate the powers. So we can say equate the powers. So I can say this 4 over this 4. So I'm now left with 2x times 1 over 3 is equals to 2. So 2x times 1 is equals to 2x over 3 times 1, 3, which is equals to what? 2. Now from here, I can cross multiply, right? So 2 times 3 equals to 6. Then this is over 1. 2x times 1 equals to what? 2x. So this is what I'm left with. So how am I going to get my divide both sides by 2? Divide both sides by 2. 2 cancel 2. 2 here 1, 2 here 3. Therefore x is equals to what? Equals to 3. This is our next question. It says simplify. Square root of 3 raised to the power of x is equals to cube root of 9. So now we want to solve this one. I told you earlier on that square root is the same thing as power 1 over 2. So we are going to convert the square root to power 1 over 2. If we convert it, we'll be having 3 raised to the power of x times 1 over 2 is equals to, then cube root is the same thing as saying power 1 over 3. So we are going to have 9 raised to the power of what? 1 over 3. If this is what we are having is equal to this 3, then we are going to multiply the power. X times 1, we have x over 2 times 1, 2 is equals to, this 9 is the same thing as saying 3 raised to the power of 2. 3 raised to the power of 2 then times this 1 over 3, 1 over 3. We have not changed anything. So this is equals to 3 raised to the power of x over 2 is equals to 3. 2 times 1, 2 over 3 times 1 over 3. So this is what we have. And now we can now equate the power. Equate the powers. Alright. So by equating the power, I can cancel the base as well. 3 cancel 3. So I'm now left with what? I'm now left with x over 2 is equals to 2 over 3. Then I can cross multiply. So if I'm cross multiply, I'm having x over 2 is equals to 2 over 3 cross multiply. So 3 times x, we have what? 3x is equals to 3x is equals to 2 times 2, 4. So I'm now left with 3x is equals to 4. Divide both sides by 3. Divide both sides by 3. 3 log of 3. So x is now equals to 4 over 3. Us to simplify. 3 raised to the power of n minus 1 times 27 raised to the power of n plus 1 over 81 raised to the power of n. If I have this as my question, first thing I'll have to do is I'll have to think critically and observe the question. Now, if you look at the question very well, my constant 3, 27 and 81, they are divisible by 3. Alright. And if you check this 21 very well, I can raise 3 to the power of a certain number to get this 21. I can also raise 3 to the power of a certain number to get 81. So let me break it down starting from that. This is what 3 raised to the power of what? N minus 1 multiplied by 21. If I say 3 raised to the power of 3 is equals to 27. Alright, then this n plus 1 close your bracket over 81 is what? Is 3 raised to the power of 4. So if I say 3 raised to the power of 4 into bracket open n, I've been able to break 27 to be equals to 3 raised to the power of 3 and 81 to be equals to 3 raised to the power of 4. Now my aim has been achieved. I'm having 3, 3, 3. The constants are now all 3. Alright? So now I can begin to think of what to do further. Now looking at this, I can apply the first law of indices when I want to work with the numerator. Now the first law of indices says if I have two indices multiplying themselves and they are having the same base, I should pick one of the base and add their power. So this is equals to, if I'm working with the numerator now, if I'm picking the base now, this will be equals to 3 raised to the power of what? N minus 1 plus, let me open this bracket, 3 times n, 3n plus 3 times 1, 3. So this is what the numerator looks like over the denominator. 3 raised to the power of 4 times n, this is 4n. This is what I'm having. Alright, now let me add these powers together now. This is equals to 3 raised to the power of n plus 3n. That's what? That's 4n. Alright. Now, minus 1 plus 3. That's what? Plus 2. Okay? Alright. I'm done with what? The addition of the power now. All over this one. 3 raised to the power of what? 4n. This is what I'm having on the board. This is equal to me saying 3 raised to the power of what? 4n plus 2. This over means divide by 3n, 3 raised to the power of what? Of 4n. This is what I'm having. I converted the question in this form to the question to this form so that I'll be able to apply the second law of indices. I've not changed anything. This guy is still equals to this one here. I only express it like this so that you quickly think to the second law of indices, which says that if I'm having two indices dividing themselves and they are of the same base, I should pick one of the base and add their power. So if I want to add this power now, I have what? 4n plus 2, then minus, since it's divided, joining them, minus 4n. Alright? So this is equals to 3 raised to the power of 4n minus 4n. I'm left with 0. So I'm left with what? 3 raised to the power of 2, which is equals to what? 9. Alright. The next question says simplify 0.008 raised to the power of what? 1 minus 1 over 3. This is the question. So now, the question inside the numbers inside the brackets is the decimal number. So we don't solve indices using decimal. It becomes cumbersome and difficult for us to solve. So first thing, we think of how to convert this decimal inside the bracket into a fraction. Now when you want to convert 0.008 into fraction, you assume this point under the point to be 1, then the rest number after the point becomes 0. So something like this. To now be equals to what? You have, this is what you are going to be left with. 0.008. I told you, assume this guy to be 1, then this one to be what? 0, then 0. So this is equals to what? 8 over what? I assume the point here. Under this point, I added 1. Then the rest number after the point becomes what? Becomes 0. How many numbers do I have before the point? After the point is 3. 1, 2, 3. So after this one, I'll have 1, 3, 0. So all these ones that are not significant dies down all over what? 1,000. So I'm left with this. So this is what I'm having. Raised to the power of what? Minus 1 over 3. Are you getting it? Alright. By so doing now, I'm having 8 over 1,000 raised to the power of minus 1 over 3. Solving this question like this with this negative will be so difficult for me. So I don't need this negative there. I have to eliminate the negative. How do I eliminate this negative? I can eliminate this negative by exchanging the fraction. I call it swapping. The one in the numerator, you bring it to the denominator. Then the one in the denominator, you carry to the numerator. By so doing, the minus is gone. This is what I mean. It's equal to the one. This 1,000 is the denominator. Take it to the numerator. It becomes 1,000 over the 8 is the numerator. Take it to the denominator. 8. Automatically, when you do it like this, you have eliminated this minus. It's now raised to the power of 1 over 3. The minus is what is no longer there. Alright, so now take note. This 1 over 3 is for both 1008. It's not just only for one of them, it's for both of them. So let's give everybody their 1 over 3. This is equal to what? 1000 raised to the power of what? 1 over 3 over 8 raised to the power of what? 1 over 3. This is what we are having. Alright, so now 1000 can be written as 10 raised to the power of 3. True or false? Yes. Raised to the power of this 1 over 3. 1 over 3. All over 8 can be written as what? 2 raised to the power of 3. Like this, then 1 over 3. So I can now say 3, cancel 3, 3, cancel 3. I'm now left with what? 10 over 2. It's equals to what? 10 over 2, which is the same thing as 2 here 1, 2 here 5. This is equal to what? 5. This question says simplify 27 over 125 raised to the power of what? Minus 1 over 2 times 4 over 9 raised to the power of what? 1 over 2. Now, let's start with this guy here. Trying to solve this guy here with this negative is going to what? It's going to give us a problem. I told you whenever you are having indices with the power of negative, if it's not in fraction, if it's something like 3, you try your best to make it a fraction, which is 3 over 1. Then you swap. This 3 goes up. This 1 goes up, this 3 comes down for you to eliminate this minus. In this case, we'll be doing the same thing. In this case, it's already fraction. So for us to eliminate this minus, this 27 that is in the numerator, we have to carry to the denominator. And this 125 that is in the denominator, we have to carry to the numerator to cancel the minus. So this is equals to what? This is equals to 125 over 27. So automatically the minus is gone. I'm left with what? I'm left with 1 over 3. Now times this guy, 4 over 9 raised to the power of what? 1 over 2. So this is what I'm left with. Now 125, I can raise, this is power 1 over 3, I will now begin to think, which number can I raise to the power of 3, this denominator, to get this 125? The aim is, after raising that number to the power of 3, that 3 should be able to cancel this 3. Alright. Now I told you earlier, whenever you have a fraction inside the bracket raised to a particular power, the power is for both the numerator and the denominator. Alright. So if I want to solve this one now, if I raise 5 to the power of 3, I will be able to get 125. So this is the same thing as saying 5 raised to the power of 3 over, what about 27? If I raise 3 to the power of 3, I should be able to, I will get 27. So this is 3 raised to the power of 3 all over what? All over 1 over 3. Raised to the power of 1 over 3 times, which now I'm on this part now. I'll be considering this denominator. Which number can I raise to the power of 2 to give me this 4 here? If I raise 2 to the power of 2, I'll be able to get what? 4. So this is 2 raised to the power of 2 over. Now, which number can I raise to the power of 2 to get 9? That's 3. If I say 3 raised to the power of 2, I've got 9. Alright. Raised to the power of 1 over 2. I've not changed anything. Now, this 1 over 3 is for both this 5 raised to the power of 3 and 3 raised to the power of 3. This power 1 over 2 is for both these 2 raised to the power of 2 and 3 raised to the power of 2. So let's give everybody what belongs to them. So this is equals to 5 raised to the power of 3 raised to the power of 1 over 3 over 3 raised to the power of 3 times what? 1 over 3 times 2 raised to the power of 2 times what? 1 over 2 over 3 raised to the power of 2 times 1 over 2. So if this is what I'm left with, 3 can cancel off, 3 can cancel off, 2 can cancel off, 2 can cancel off. So I'm left with what? This is equals to 5 over 3 times 2 over 3. So this is what I'm left with. Okay, so 5 times 2